We are on day 3. We are looking at chapter 3. This is when we did systems of equations. Systems of equations is when we have 2 equations and we have to have 2 variables. We had word problems and we also solved them in different ways, and then we have a weird thing, okay? So this one says we have an agency that's going to charge us an initial fee of $30 and then $25 per hour. A different agency is going to charge us $50 and $15 per hour. Okay. We want to write an equation for both of them for how much money they're going to charge us and for how many hours. Okay. So we need 2 variables. So I'm going to say T represents our total money. And they both keep talking about hours. So I'm going to say H represents our hours. Okay, so as I said, since we're doing systems of equations, we need to have 2 equations. I'm going to write one about the first agency. So I'm going to say T equals, they charge us 30 and then $25 per hour. Okay, whereas the other agency charges us more at the beginning. They charge us 50, but only $15 per hour. Okay, does this look familiar? Okay, all right, so now we want to find when these are going to equal, so we want to know how many hours that will take. There's 2 ways you could do these. You could plug this into your calculator, graph both of these, and see where they cross, or we could solve it using our techniques. Does everybody see how they both equal T? So since they both equal T, I'm actually going to set them equal to each other. So I'm going to say 30 plus 25H equals 50 plus 15H. And now we're going to solve for H. Luckily, we reviewed solving last week. So I'm going to get my H's together. I'm going to also move this 30 just because I'm going to be lazy and do this all as one step. 30s are canceling. I'm left with 10H. And this is 10H. And this equals 20. And that's canceling over there. So H is going to equal 2. So that means it's going to take 2 hours before these 2 companies equal the same thing. Does this look and sound familiar? Okay. All right, I'm going to have you guys flip. I answered it by. All right. So we should have this for T for total, M for months. We should have those 2 equations. And did everyone get C? Oh. Did everyone get C? Okay. I'll give you guys this answer in case you want to look at that later. All right, so that was word problems. So you have to write them and solve them. If you remember in chapter 3, we also taught you 2 different ways to solve. I'm going to be honest, you guys were better at elimination. I would say you guys should use that method. So if you remember, the elimination method is when you're trying to get the same number in front of your X or Y. Okay. Then remember, you are either able to add or subtract your 2 equations together. Okay. Sometimes we are left with true statements, so something like 1 equals 1. If that happens, reminder, your answer was infinitely many solutions. Okay. If you were left with a statement that was false, like 2 equals 3, then we had no solution. Does that look and sound familiar? Okay. So if I look at this first one on the left, I see that my y's both have a 1 in front of them. 1 is positive, 1 is negative. So what I'm going to do is I'm going to add these 2 together. And when we add these 2 together, I'm going to have 2x plus 3x, which will give us 5x. Our y, since I have a positive y and a negative y, and if I add those together, our y's will cancel or they'll eliminate. And then over here I have 7 plus negative 2, so I'm going to have 5. We'll divide, and x will equal 1. Okay. Reminder though, when we did these, our answers, they were ordered pairs. So I know x, and now what I'm going to do is I'm going to plug it back in to find my y. And remember, you can plug it into either equation, it doesn't matter. I'm going to plug it into the top one just because there's no negatives. Okay, use our solving skills that we've been using all year. And y is going to equal 5, because I'm subtracting 2 from both sides. So y is going to equal 5. Does this look and sound familiar again? Okay. This one, if I notice this one on the right side, I don't have the same numbers in front, but I do see that I have a 10 here and a 2. So I'm going to multiply this whole equation by 5. Okay. So what I'm going to have now is 15x plus 10y equals 35. Okay. This time they're both positive, so instead of adding them together like we did on this first one, we're going to subtract them. And when we do that, our x's are going to cancel, our y's are going to cancel, so we're just going to be left with 0. When I subtract these two, I'm going to be left with negative 5. And this is a false statement, so our answer is going to be no solution. Yeah. Okay. I'm going to go back to this first one. If you forgot to do this, could you also do a guess and check? Could I plug in these values and see which ones works? Yeah. Okay. Do 58. Do 58. All right. Did everyone multiply the top equation by 2? Okay. And then you ended up with the same thing, so everything canceled, so you should have left with 0 equals 0. So everyone got A? All right. Any questions on elimination? All right. The last thing we're going to do in Chapter 3, it's kind of a weird thing. This is when we did what we did last week where we had lines that we had to graph. There was shading. We made a shape. We plugged the points in, and then we tried to find our max. Does any of this sound familiar? Yes. Okay, good. All right, so let's go through first. Let's graph these lines so we have a general idea. Then we'll talk about our shading. So remember these, when it's x equals, that's going to be a vertical line. So I have a vertical line here at 1. Oh, that's terrible. All right, I have a vertical line at 1. When it's y equals, I'm going to have a horizontal line here at 2. So if I look here, I already have a point that they cross right here, so I know that's going to come into play later. I have a horizontal line here at 5. So again, I have a point that they cross. Okay. This line here, luckily, we were graphing these yesterday. Is this one ready to go? No, reminder, it has to be in y equals mx plus b. What form is this in right now? Standard. Okay, so what I have to do is I have to subtract the x. So I'm going to have y is less than or equal to negative x plus 7. So now we're going to start here at 7, and then we're going to go down 1, right 1, down 1, right 1. Oop, I got another point they cross. And I have another point they cross. Okay. All right, if we look at what we were talking about for shading, this one says we're greater than, so these two say we're going this way, whereas these two lines here say we're shading down. So our shading is this weird trapezoid thing here in the middle. Do you guys remember doing this back in Chapter 3? Okay. So we have that weird trapezoid thingamabobber, and now what we're going to do is we're going to take all these points where the lines cross to make the vertices of our trapezoid. So I see I have a point here at 1, 2. I see I have a point there at 1, 5. I have a point at 2, 5. And I have a point at 5, 2. Okay. So then remember, after you find these points, we then plug it into the objective function. Okay. So this is going to go in for all of our x and y's. So I'm going to say 2 times 1 plus 3 times 2. 2 times 1 plus 3 times 5. And we're looking for which one is going to give us our max. Usually we ask for max. Sometimes we might ask for min. Okay. So this one I'm getting 8. Is everybody okay with that? 8. I'm getting 17, 19, and 16. Is everybody okay with those totals? Okay, so then if I was asking for our max, this point here is our max, and it has a max of 19. Okay. How's everyone doing? Okay. All right, so we're going to start with chapter 4. There is some chapter 5 stuff mixed in here. This is when we were square rooting and factoring. Have we been doing that for like the last 2 months? Yeah, so hopefully this will go by really fast. This first one here, this is when we were solving by square rooting. Reminder, when we're doing that, we're trying to get the x squared by itself. So reminder, you're trying to get it to say x squared equals a number. And then reminder, whenever you square root something, you always have a plus and a minus. And then also, if you ever square root a negative, you will have an I. So all things we've been talking about a bunch. So this one's not ready to go. What do I have to do to both sides? I have to divide by 4 is I think what I heard. Yes. All right, so I'm going to divide by 4 on both sides. So now I have x squared equals 5. So now that it's like this, we can square root both sides. Things that we've been doing quite a bit. 5, not a perfect square, so our answer is just going to be plus or minus square root of 5. Can we handle those? Yeah. This one a little bit different. I'm going to subtract 9 this time, so I'm going to have x squared equals negative 9. Again, we can square root now. 9 is a perfect square, but I do have a negative, so we're going to say x equals positive or negative 3i. We already see the difference between those two. Okay. Our last one here, I have to subtract the 100, and I also have to divide by 2. So I'm going to have x squared equals negative 50. Now, when I square root, this one does have something weird. 50 is not a perfect square, but what can I do to 50? I can do 25 and 2, yeah. So all things we've been doing. So I'm going to say x equals plus or minus 5i square root of 2. Oh, that's an ugly looking I. Okay. Do we see the difference between these three? Okay. Do number 61. All right. I hope everyone added the 14. I hope everyone divided by 2, and I hope everyone square rooted it, and everyone got C. Okay. All right. That's square rooting. Can you handle that on your final? Yeah, we've been doing that a ton. All right, so now we're going to enter into our factoring. We have been factoring since like November. We have a ton of different ways, so this is probably our largest area just because there's so many different ways of factoring that I've taught you. Okay. The first one and the most important one is finding a GCF, looking to see if you can take out something first. I'm going to always tell you to do that, see if you can take out something first. So if I look at this one, it says factor, so what do I see I can take out of all three of these? They're all divisible by 2, but yeah, we want to take out a negative, never ever leave with a negative. So I'm going to take out a negative 2. When we do that, I'm going to be left with x squared plus 12x minus 24. Are there two numbers that multiply to negative 24 and add up to positive 12? It's Tuesday. I'll help you. No, there's not. That's as far as we can factor. You're welcome. Okay. If I were to say solve this and you can't factor it, how would we have to solve this part now? Yeah. The quadratic formula. But luckily I didn't say that. Now this one, if everyone notices, it says solve, and we also know we have to solve because it equals 0. Yeah, that's how we know we have to solve. On this one, what's my GCF? X. I can take out an X. So now I have 1x, yeah. I've got x squared minus 6x minus 16 equals 0. Are there two numbers that multiply to, I'm listening, what? 18, or 8 and 2, does that multiply to negative 16? Subtract to negative 6? Yeah. So I'm going to have x minus 8 and x plus 2. Okay. Now, how many answers are we about to get? 3. Should we get 3 answers? Yeah, we have x to the third up here, so I know I should have 3 answers. This x chilling out front, what does that always equal? 0. Okay, so this one equals 0. Reminder, you just flip the sign, so this x is going to equal positive 8, and this x is going to equal negative 2. Okay, that's our first type of factoring, GCF. Factor if you can factor. Can we handle it? Okay. Our next one, we didn't take a full day out of this, but I think you guys can do this without me. It says that we have our perfect square trinomial, so we know there's going to be perfect squares in here. And we're going to write our answer as a single binomial squared. I'll explain what that means. 25, perfect square. How do we get it? 5 and 5. 9, 3 and 3. Guys, what's 5 times 3? What's 5 times 3? If I add 15 and 15, do I get 30 here? Yeah. So what we're going to say is we're going to say 5x, notice it's a negative 30, so I'm going to say negative 3, and 5x minus 3. As Algebra 2ers, should you leave your answer like that? No, this is happening twice, so we're going to write it as a single binomial squared. So I'm going to say 5x minus 3 squared. How are we doing? Okay. All right, we're going to get into our more recent factoring. Okay. This next one, some of us struggled on our test right before winter break. This one is factor by grouping. We know we're going to have factor by grouping because we have 4 terms or 4 things. Okay. This first one we're just factoring. So if we notice in front here, in my first group, what can we take out of both of those? An x squared. Okay. When we do that, we're going to be left with x plus 2. In my second grouping, what can we take out? A plus 3. Oops. A plus 3. And again, we're going to be left with x plus 2. If you were left with something else, you've done something wrong. And reminder, when we factor by grouping, these are the same. So that represents my first one, or our first factor. And our leftover junk forms our second factor. Do we remember this? Okay. This one I'm going to put a star on it. I'm going to flat out tell you there's one like this on your final, and it has something sneaky in it. Okay, so I'm giving everyone that hint. I'll know who's listening to me right now. All right. Again, we're factoring by grouping because it's in this section, and there's 4 things. In this first section, we should take out an x squared. When we do that, we're going to be left with x plus 5. In our second grouping, what should we take out? A negative 4. And again, when we do that, all of our negatives flip, so we're left with x plus 5. So we know we did that correctly. Okay. Same thing, same thing. So that will form our first group, or factor. Leftover junk forms our second one. Now there's something sneaky that's happening here, because there's another one of our factoring that we've snuck into this problem. This right here, ladies and gentlemen, is difference of squares was just whispered to me. It clearly says difference up there. Okay, so this one we're actually not done. The x plus 5 can't do anything with that. But the x squared minus 4, reminder, when we do difference of squares, I'm going to have a plus, I'm going to have a minus, so I'm going to have x and x. And how do we get 4? 2 and 2. So that's actually our factored answer. Okay, so that's going to come up secretly a couple times. Questions on that? Okay. This next one, I need you guys to study this. We will not give this to you. You do have to have this memorized. Did I just test you on this? Did some people not have it memorized? All right, so we have to have this memorized. What do we remember about this right here? How do you have to solve it? Quadratic formula. Okay. And what is always going to be in your answer? A negative, which causes an I. Okay. All right. The first one, we're just going to apply the rule. The second one, we're actually going to solve. Okay. Is everybody okay for me to erase the blue up there? I've run out of space. Is everybody okay? They wrote the difference of square crap? Okay. All right, good. All right. So this one, I notice I have a plus. So I know I'm going to start with a plus here. To get x to the third, that means I cubed an x. And to get 1, I just cubed a 1. Yes. Now we apply the long part of the rule. This is where we struggled on our test. I square this. I flip the sign. I multiply these two together. And then I square this at the end. Okay, that's it on that one. So I will say you guys do need to have this memorized by your test. Okay. This one we know we're solving because it equals 0 and it says solve. How do I get 27? What did I cube? 3. Okay. So we're going to have x minus 3 because it's got to match that. So now I'm going to have x squared. Flip your sign. Multiply these together. And square the 3. Okay. The x chilling in front, what does that one equal? 3. Okay, so that x equals 3. And what do I have to solve for this? Okay, the quadratic formula. Okay. So now I have negative 3 plus or minus 3 squared minus 4 times 1 times 9 all over 2 times 1. As you guys can see, we also have to have the quadratic formula memorized. Okay. I'm going to write my work over here. I'm going to assume people are done with this. Inside there, I'll help you guys out. Inside there, we're going to be left with negative 27, which is exactly what we're supposed to get. On bottom, we have 2. What should we do with 27? 9 and 3. Yep, 9 and 3. So now we're going to have negative 3 plus or minus 3i square root of 3 all over 2. Can we reduce anything, get rid of anything? Nope. Okay, so those are our 2 answers. I'm going to be honest, every year that's probably the one problem like most of our students get wrong because there are a lot of parts to get wrong. Yeah. Okay. All right, we have these 2, and then I'm going to have you guys try some, and then we're going to be done. All right, the last time form of factoring, again, this was on our last test, is when we have x to the 4th. Reminder, to get x to the 4th, you have to have x squared and x squared, and then after that, it's like regular factoring that we did like back in Expo. I need 2 numbers that multiply to negative 20 and add up to positive 1. A 5 and a negative 4. Now I want to pause here. Are we being sneaky again? Yes, this right here is really difference of squares. Thank you. Okay, can I do that on this one? Is this one difference of squares? No, so I'm just going to bring this one down. And this one right here is going to turn into x plus 2 and x minus 2. So if it says factor, you need to try to factor it as far as you possibly can. Okay, so that's your answer on that one. Whereas our other one says we're going to solve. Okay, what's wrong with this one before we even start it? doesn't equal 0, so I'm going to add over the 12 right away. And then we're going to factor, so I'm going to have x squared and x squared. Okay. I need two numbers that multiply to 12, add up to -7. 4 and 3, okay, so they're both going to be negative. Now, if I said factor, obviously I would have you guys do some stuff, but since we're solving, we're going to do something else. Reminder, we're going to set both of these equal to 0. And then are you going to do something we've already done today? Did we solve these already today? Do we solve them by... How do we solve these? Square rooting. Yep. So you're going to add over the 4 square root. So this x will equal 2. Just 2? Plus or minus 2. Okay. So this x will equal plus or minus 2. And this x will equal plus or minus square root of 3. Oh, and that's all the ways I've taught you to factor in Algebra 2. Jeez. Okay. All right. Do 68 and 70. All right, did everyone take out a 2x first? Okay, and then you were able to, 2x, and then you guys were able to factor x minus 5 and x minus 3. And then this one, number 70, was the perfect square thingy-mabobber. So I'm hoping everybody got a C there. Notice there's a negative here, which means we need a negative down here. Okay, all right, we're going to do a couple more, and then we're going to be done. I need you to do 72, 72, 74, and 77. 72, 74, and 77. All right. On the first one, I hope everyone did some factoring by grouping, and everyone should have had an x squared plus 5 and an x minus 3. This one, I hope everyone noticed that we kind of gave you a hint that because there's an extra line here, we're kind of giving you a hint like there's 2 lines there because of difference of squares, so we try to give you guys those hints. So we're going to have x squared plus 6, and then you should have x plus 3 and x minus 3. So that's why we gave you an extra blank so you would catch that. I'm going to write down the rule for this one. I hope everyone for their rule had x plus 2. You then would have x squared minus 2x plus 4. So that means this x chilling out here ended up being -2. Is there an answer on here we could have crossed out? Yeah. Is there one without an I? Yeah, reminder. So you should get rid of that one right away on your test. It has to have an I for you guys to be correct. This one, when you plug it into your quadratic formula, a bunch of stuff cancels out. So you're just left with this for this one. All right, that's chapter 3 and chapter 4.